So what we're going to take a look at today is what happens when the degree of our numerator is higher than the degree of the denominator. So when we take a look at this example, we know that this is going to end up factoring to the x plus 6 times x minus 3 all over x plus 2. So I have no whole. I have one vertical asymptote at x equals -2 because we set our denominators to 0. Well, I actually don't have a horizontal asymptote because what I'm going to be dealing with is a slant asymptote. So anytime the degree of the numerator is larger, once you're done simplifying and everything, is you're going to encounter a slant asymptote. And so I'm going to show you guys how to find what that slant asymptote is. But we're going to find everything else first. So I can take a look at this, and I know that my x-intercepts I can find by setting my numerator to 0. So I have -6, 0, and 3, 0. My y-intercept, I can plug in 0 or look at the ratio of the constants. So my y-intercept is going to be 0, -9. Now, then we encounter this slant asymptote. And so what we need to be able to do as we look for our slant asymptote is we're actually going to have to divide the numerator by the denominator. Now, what's really nice about this question is that we can actually do synthetic division when we do this. So my divisor right now is x plus 2. So when I go to do this division, remember we line up the coefficients. So I have 1, 3, and -18. And then I'm dividing by x plus 2, so here I'm going to put the 0 that goes with that, which is the -2. So as I go through this process, I drop my 1, multiply, so what this actually leaves me with is it leaves me with my slant asymptote, which would be y equals, I divided by x plus 2, so we know we're going to drop a degree. So I end up with x plus 1 plus -20 over x plus 2. Whoa, sorry, I went off the screen. Now, it's actually this -20 over x plus 2 that I need to talk to you about. And the reason is we ignore it. My slant asymptote is just the line y equals x plus 1. Now, the reason for that is that as x is approaching infinity, as x is getting bigger and bigger and bigger and bigger, -20 is going to be divided by numbers that are getting so large that this is going to end up yielding towards 0, which means we don't really need it. So when you're looking for your slant asymptote, we're just looking for the equation that we get before the asymptote. So this is telling me that the line y equals x plus 1 is going to be my slant asymptote. So when I go to graph this, I know that I have a y-intercept of 1. The slope is 1. So I'm going to do as many points as I possibly can, just because I like to. Okay. I know that my vertical asymptote is x equals -2. And now I'm going to plot the other points that I know. So I also know I have -6, 0, 3, 0, and 0, -9. Now, the last thing that we have to do is we have to check and make sure that we are not crossing our slant asymptote. And so just like we were checking to see if we were crossing our horizontal asymptote, we would set the equation equal to the horizontal asymptote. Well, what we're going to do here, in order for us to see if I'm going to cross the slant asymptote, is I'm going to set my function equal to my slant asymptote. And yes, it's easier to use the original as long as there were no holes. So when I go to do this and I go to cross multiply, I'm left with x plus 1 times x plus 2 equals our x squared plus 3x minus 18. And so our x squareds cancel, our 3x's cancel, and we're left with 2 equals negative 18. And again, I went off. I don't feel like trying to redo that. So, there's no solution. So it does not cross the slant asymptote. Now, when I go back up here, I now need to figure out where my curves are going to go. Well, this is my vertical asymptote. And so what ends up happening is I end up having to deal with the situation where I have to see, is my curve going to be in here? Or is it going to be in the lower right? Well, clearly I have 2 points here. So what that's telling me is, yeah, it's going to be in that lower right. Now these are a little harder because they're kind of wide, but I know that that's where that one's going to have to be. Now, if I take a look at this side, I have to decide or determine if this is going, my curve is going to be below this slant asymptote in this little region, or if it's going to be above in this region. Well, I already have a point there, so I know that it's going to be above. And so what this means then is that in the past, when we've been looking at as x is approaching infinity and as x is approaching negative infinity, well, what's been happening with our functions is they've been approaching the horizontal asymptote. But I don't have a horizontal asymptote here. I have a slant asymptote. So let's take a look at what's happening. As my x's are getting bigger and bigger, my graph is approaching what? As my x's are getting smaller and smaller and smaller, what's the graph approaching? As my x's go all the way to the left, what's the graph approaching? And that's something that we will discuss when I see you in class next.